Good morning, class. I hope everybody had a restful spring break. And as we start a new unit of material, this chapter is on the topic of probability. In today's lesson, we're going to be looking at tree diagrams and the counting principle. So to start off, there are three important definitions that you need to be familiar with as we go through some problems in this lesson. Here are your definitions up here at the top. We have outcome, event, and sample space. So an outcome is the result of an action. An event is an outcome or group of outcomes. And a sample space is the set of all possible outcomes. So here's an example of a mock lunch menu for a school. And let's suppose that this school's lunch menu is offering two different choices of sandwiches to pick from. We've got roast beef and turkey, and then the school is offering also three choices of fruit as well. So we have orange, apple, or banana as our fruit combinations. So what we need to do is figure out all the total number of ways that we can group each sandwich choice with a fruit option. So what I'm going to do to figure out how many possible ways that we could arrange these types of things is by using something called a tree diagram. So the tree diagram is pretty straightforward. So you'll notice I've got two different categories to choose from. I've got sandwiches, and then I have my fruit. So here's what I'm going to do. I'm going to use R for roast beef and T for turkey, then O for orange, A for apple, and B for banana. So let's start with, let's suppose for our sandwich we pick roast beef. Now with the roast beef, we've got three different fruits that we can group that with. So we can group a roast beef with an orange, or a roast beef with an apple, or roast beef with a banana. So we've got three different ways that we could pair those options with each other. Or, we could, let's suppose we didn't want a roast beef sandwich. Let's suppose we wanted a turkey sandwich. Well, with the turkey sandwich, again, we've got the same grouping options with the choices of fruit. We can group a turkey sandwich with an orange, or an apple, or a banana. So by doing this method, it gives us a more visual way of looking at all the different ways that we can group together all the possible combinations of things from the school lunch menu. And so if we count these all up, we have 6 choices to choose from. So that's how we can use a tree diagram to help us to make better sense of all the different choices that could be available from different groupings or categories of things that we're comparing with each other. And so we can use this not only with school lunch menus, but we can also do this with maybe items in the store that we buy, like maybe different types of pants to different colored shirts to different pairs of shoes. So there's a variety of different ways that you could use this principle in order to look at all the possible choices. Now, other than using this method right here, which is, again, this is what we call a tree diagram, there's another way that we could find the number of choices as well. And choice number 2 is going to use something called the counting principle. So the counting principle, by definition, is this statement here. It says there are m ways, so we're going to use a variable. There are m ways of making one choice and n ways of making a second choice. There are m times n ways to make the first choice, followed by the second choice. So we can use an algebraic operation of multiplication with the number of choices. Now, we can extend this further too. It doesn't always have to be just 2 choices. We could have 3 choices. If that's the case, then we would do m times n times another variable. Now, let's take a look at this example. Let's build off of that first example of school lunches. And let's suppose we have this. A school lunch menu gives options to choose from 3 sandwiches, 2 fruits, and 2 desserts. What are the total number of choices for lunch? So the first choice has 3 sandwiches to pick from. The second choice has 2 fruits. And the third choice has 2 desserts. Now, if we were to use the tree diagram method, let me show you something. If we were to use the tree diagram method for this problem, as you can see here, we could still do it, but it's just going to be a little bit more involved, and the drawing is going to be a little larger because we have a bigger web of options to choose from. And so you can certainly do it that way. There's nothing wrong with that at all. Just keep in mind it may take you a little bit of time to map everything out and then count up the total number of choices, which the answer would be 12 in this case. There are 12 total choices. Now, let me demonstrate how we can find the answer much more quickly using the counting principle. So if we go back to our example here, where the first choice had 3 sandwiches, the second choice had 2 fruits, and the third choice had 2 desserts, then we can just multiply these 3 values together to find the total number of choices. So 3 times 2 is 6. 6 times 2 is 12. So there are a total of 12 choices that a student can make for grouping together a different type of sandwich, fruit, and dessert with each other. Tell you what, let's pause the video right here for a moment, and I'm going to show you another example. Here's another example. This problem says, you choose from a model car, plane, or boat, and each model comes in 4 colors. How many choices do you have? Well, the first choice is dealing with the type of vehicle that we're working with. So we have a car, a plane, or a boat. So the first choice has a total of 3 options to pick from. And then each model comes in 4 colors. So how many choices do you have? Well, first choice, there's 3 options. Second choice has 4 options. So 3 times 4 gives you 12 choices altogether. So I hope you found this example helpful. And if you have any questions about the lesson, feel free to email me, and I will be glad to help you out in any way that I can. Thank you.